Does anyone know how to bring this screen to be one?
Double click on your screen alone.
This one?
Yep, just double click on. Same. Oh,
Don't know what's-
I'm not sure if you're using screen sharing. It's live on YouTube, but it's a screen.
Yeah. Are you ready for your exam on Friday? Okay, so you read, make sure you read chapter 5. Chapter 5, we only have one section, right? I think it's 5 or 2. I think so. It's only one section. And then chapters 6 and 7. So in each of those sections that we did, there is one question there. Okay. So each of the section. So if it's 5.4, there is one question. If it's 5.4a, b, like that. So we have one question in each one of them. So make sure you study your notes well. Okay. So you can read, make sure you read your notes very well. Most of the things are related to what we have done. So you will do your exam at home. So on Friday, during the time of your exam, so you log in into Moodle. I'll send you the link. So I'll just be watching you in Moodle. So you do your exam within the stipulated time. So when you're done, then you scan. So try install I don't know whether you can install the CAM scanner. That's what I usually use. I use the CAM scanner in my phone. So I scan and then I convert to PDF. So you scan the old document and then you convert to PDF. So it will send as one file, okay? So when I'll be grading, it will be so simple. Some of you were scanning, but it was coming as a very big file that I could not even open it. So scan, try. So maybe I will make a quiz today, and then we do a demonstration. You do it, and then you scan, and then you send. I'll see whether it will be clear or not. Okay. So when you will be done with your exam within 1 hour, I think 1 hour, 15 minutes there, then you scan and then you send it through the Moodle or through the email. Okay. So we'll still discuss about it on Wednesday. All right. So the questions, it will be out of 100. So it will be 100 points. So it might take a lot of time for you to do it, but you need to do it very fast. All right, so today we're doing the last section of chapter 7, which is section 7.6, and this one is so this is where we solve rational inequalities. So rational inequalities. So rational inequality is an inequality that contains rational expression. So rational inequality is an inequality that contains rational expression. For example, 3 all over 2x greater than 1. Another one, 2x all over x minus 3 less than maybe 4. Another one, maybe 2x minus 3 all over x minus 6 greater or equals to x, and maybe 1 all over 4 minus 2 all over x squared less or equals to 3 all over x. So this is an inequality. This is greater than. This is also an inequality, less than. This is an inequality greater or equals to. And this one is also an inequality less or equals to. So these are rational expressions. So this is a rational expression. This one is also a rational expression. The two of them are rational expression, and this one is also a rational expression. So, so we want to get a way of solving these inequalities and representing this one in maybe a number line, or representing it in an expression form or in a rational notation form. All right, so we have some steps of solving this. So how to solve rational expression or rational inequality. So how should we solve the rational inequality? So how to solve rational inequality. How to solve rational inequality. So one of the steps is, so we have like 6 steps of solving this. So number one, write the inequality as 1 quotient on the left and 0 on the right. So number one, write the inequality as 1 quotient on the left and 0 on the right. So write the inequality as 1 quotient on the left and 0 on the right. So for example, this. So if you have 3x, if we have 3 all over 2x greater than 1, if we have 3 all over 2x greater than 1. So what you do is you make sure the other side is what? Is 0. So the other side of the expression should be 0. So that means you bring this one to what? To this other side. So when you bring this, then it will be 3 all over 2x greater than, minus 1 greater than what? Greater than 0. So that is the first step. So you make sure you put once the equation or the expression in one side, and the other side should be 0. Okay. Number 2. So number 2, determine the critical points. Determine the critical points. Determine the critical points. So the critical points, these are the points where the rational expression will be 0 or undefined. So these are the points. So these are the points where the rational expression is A, 0, number 2, or B, and defined. The critical points are the points where the rational expression is 0 or undefined. For example, 2x all over x minus 3 less than 4. Okay. Okay, before, let's say this one is 0. Let's put this one to be 0. Because we need to follow the first step, so you make sure that one side is what? Is less or equals to 0. So the critical point here is at this point when x is equals to 0. So the critical point is when x equals to 0. So that's a critical point. Another critical point here is when x is what? When x is 3. So that it becomes what? 0. Undefined. So that this expression can become undefined. Okay. So when you put here x minus 3, like for example, if this one was not there, okay, so if it was 2 all over x minus 3 less than 0, then at the point where x is equals to 3, so at the point when x equals to 3, then this will be what? Undefined. So this one will be undefined. So this x equals to 3 is a critical point. So you identify or you determine the critical point. So that one is step number 2. Number 3, use the critical points to divide the number line into intervals. So use the critical points to divide the number line into intervals. So use the critical point to divide the number line into intervals. Okay? So if we, for example, this one that we have done here. So you use this now because x is 3. So you use this one. So let's say this one is 3. So this is x and this is y. Okay? So this is now our critical point. So we use this one to get so we use this to divide the number lines into the interval. So we have at this point x equals to 3. So we use the critical point. If there was another one, like for example, x equals to 0, then that is another point. So where we use a critical point to divide the number line into interval. So we will see an example and then some examples of that. Number 4. Test a value in each interval. So test a value in each interval. So you test a value. So you can get a value after the interval or before the interval. And then you test it on that expression to see whether it's greater than 0 or less than 0. Okay, we'll see some of the examples of that. Number 5. Determine the intervals where the inequality is correct. Determine the intervals where the inequality is correct. So you get a point, so you can use a trial and error to get a point where the interval will be correct. So we'll see on that. And then finally, number 6 is write the solution in interval notation. So write the solution in interval notation. So those are the 6 critical points that you need to solve a rational inequality. So those are the critical points or the steps you need to use to solve the rational inequality. Right, so again, if you still remember what we did in when we were solving the inequalities. So we said, so the critical points that you need to understand is 1, when you multiply or divide by a negative, then what happens to the inequality sign? It's reverse, right? So you need to remember this. You reverse the sign. So you reverse the sign. So this is so important. So make sure you remember that. All right, so let's come to example number 1. And you have them in your notes. So example number 1, solve the rational inequality. Write the solution in interval notation. So we have the rational inequality. So solve for all over x squared minus 25 greater than 0. Greater than 0. So, and then write the solution in interval notation. So what was our first step? So we have the steps there. Write the inequality as 1 quotient on the left and 0 on the right. So at this point, number 1 is what? Is fine, huh? Because we have the 0 in the other side. Number 2, determine the critical points where the rational expression is 0 or what? Undefined. So how shall we do step number 2? So we do what? We equate this one to what? 0. When this one is 0, then this one will become what? Undefined. And we will get the critical points from there. So let's look for the critical points. So x squared minus 25 equals to what? Equals to 0. So what are our critical points?
-5.
So this is what? A difference of 2 squared. So we have -5. So x minus 5, x plus 5 equals to what? 0. So what are our critical points? So our critical points are when x equals to 5 or when x equals to what? -5. So our critical points are when x equals to 5 or when x equals to -5. So step number 3. Use the critical points to divide the number line into intervals. So now use the critical points. So you have the 2 critical points there. Now you draw the number lines. So this is 0. This is, let's say this one is -5. And let's say this one is 5. So this is going that way. So this is y. Let's say we can just say this is x. So this is a number line. So it's going that way. Okay. All right. So that is step number 3. Step number 4. Test a value in each interval. Test the value in each interval. So here, okay. So when you put x to be equals to 5 at this point, okay. So when you put x to be equals to, let's say 5 here, so it will be 5 squared minus 25, which will be 4 all over what? All over 0, right? So what do you do there? So that means we exclude the values of what? 5, right? So we exclude those values because it will give us the undefined. So that means we are not. So you remember what we were doing with the number line? The inclusion and exclusion, right? So when it is -5, when you put -5 here, then it will be 0, it will be undefined. So we definitely do what? We exclude those values. So what were we doing when we were excluding? We were using the parentheses, right? And then we had the arrow for the inclusion, right? You remember that? Yes. Okay, so here we now use these are now the intervals. We have formed the intervals. So there is this place here, this side. There is this section, which is the middle section, and there is this other one, which is after the 5. So we take any points. So we can take the point x is equals to -6 there. We can take the point for this section to be x equals to 0. And then we take the points at this section, x equals to what? Equals to 6. And then we test whether it will be true for this inequality. So okay, so let's start from this point. When x equals to -6, when x equals to -6. So now you bring this x equals to -6 to this rational inequality. So you get 4 all over so let's do it again here clearly. So we have the number line there. So we have 0. This is this is 5. Goes that way. This is -5. Goes that way. So let's start from this interval here at this section here. So when x equals to -6, what happens to the inequality for all over x squared minus 25 greater than 0? Will this one, when you slot x equals to -6 here, will it be greater than 0? So let's look at it. So let's bring x -6 here. So it will be 4 all over x, which is -6, right? Square minus what? 25. Will this be greater than 0? Will it be greater than 0? So when you put here, so this is 36, right? So 36 minus 25, right? So it will be what? 4 over what? 4 over 11. Is this one greater than 0? Yes. So this one is what? This is true. Okay? So any point, that means any point on the left after 5 is what? Is agreeing with the what? With this expression. Now, let's come to this interval. Let's take any, like x equals to 0 in the middle one. So let's take x equals to 0. So x equals to 0. So our expression is 4 all over x squared minus 25 greater than 0. What will happen when x equals to 0? So 4 all over 0 square minus what? 25 greater than what? Greater than 0. Is it greater than 0?
Yeah.
So we get what? 4, which is minus 4 over 25. Is this 4 minus 4 over 25 greater than 0? It is not, right? So this is not. So that is not. Now, let's go to after 5. So after 5, so we can take x to be 6. So let's take x equals to 6. So when you slot x equals to 6 in our rational expression, so we have 4 all over x squared minus 25. And this one is 6 squared is greater than 0. Will it be greater than 0? So it will be 4 over what? Which is greater than 0. So that is what? That is agreeing with our expression. So what can we see from here? So number 4 is test the value in each interval. So we have tested the value in each of the interval. Then number 5, determine the interval where the inequality is correct. So where is the interval where the inequality is correct? So we have gotten here is what? Correct, right? So it will be what? Are we including 5? So it will be like that. Okay? And then it will go. It will go to the left. At this interval between -5 and 5, is it correct? It is not correct. So that means this place we just leave it blank. Okay, at this point, is it correct? After 5? Yes. Are we including 5? No. So that means it will be like that. And then it goes, yeah. Then lastly, step number 6, write the solution in interval notation. So write the solution in interval notation. So how should we write our solution in interval notation? So our solution would be like what? So we have minus infinity, right? For this side of -5, so we have minus infinity, and then we have what? -5. And this -5 is not. And then we also have this section, this other section. Are we including this? So that means this one is what? This is all, right? So the union of what? This section. 5, and then what? Infinity. And then we are not including 5, and like that. So this is what? This is our interval notation. Are we together? Is it clear? All right, let's do another example. Let's do another example here. Let's do example number okay, this one. Solve the rational inequality and write the solution in interval notation. So let's solve this. X plus 8 all over x plus 3 greater than 0. X plus 8, x plus 3 greater than 0. Step number 1 is okay because one side is greater or equals to 0. Step number 2, determine the critical points where the rational expression is 0 or undefined. So which one will give us 0? Which one will give us 0? -8, right? Which one will give us undefined? -3. So the one which will give us 0 is when x plus 8 equals to 0. So x equals to what? -8. So this is our critical point. So this is our first critical point. Our next critical point is when it is undefined. So that means when it is undefined, then the bottom one should be equals to what? 0. So x plus 3 equals to 0. So our critical point here is x equals to -3. So this is our next critical point. So we have gotten to critical points. Now, step number 3. Use the critical points to divide the number line into intervals. Now use the critical points to divide the number line into intervals. So we have, so we come to the number line. So all of them are in the negative side. So we can put here 0, and then we can put here -3, and then we can put here -8. Okay. So the intervals are this. So we have that, we have this. So we have after 8, and then we have between -8 and -3, and then we also have after -3. So those are the intervals. Now we take the points, any points. So starting from after 8, so we can take x to be equals to -9. Between -8 and -3, we can take x to be equals to -5, okay? And then after -3, we can take x to be equals to what? We can take x to be -9, -5, and 0. All right, so so we're done with step number 3. We go to step number 4. Test a value in each interval. So test a value in each interval. Now we have this expression x plus 8 all over x plus 3 greater than 0. Okay. So the first one, let's test when x equals to -9. When x equals to -9, what will happen? So where there is x, you put -9. So we have -9 plus 8 all over -9 plus 3 greater than 0. Is it greater than 0? So we need to determine whether it is greater than 0. So -9 plus 8. Get minus what? -1. All over -9 plus 3. -6. Is this greater than 0? It is, because this negative and that one will be positive. So you get 1/6. That 1/6 is greater than 0. So that means any region after -8 will satisfy that expression. Okay? Now, so any region here. So that means it will be like what? Are we including 8?
No.
So it will be that way. So it goes that way. Okay? All right. So we come to another one. When x is -5, so when x equals to -5, how will that expression be? So you slot in -5 here from here. So we have -5 plus 8 all over -5 plus 3. Is this greater than 0? Is that greater than 0? So -5 plus 8 is what? 3, right? All over -5 plus 3 is what? -2. Is this greater than 0? It is not, right? So this is not greater than 0. So this one is not greater than 0. So we don't include that region between -3 and -8. All right, so let's come to the other side. So let's come to the other side. When x equals to 0, so when x equals to 0, how will that expression be? So 0 plus 8 all over 0 plus 3 should be greater than 0. Is this one greater than 0? Yeah. So 8 all over 3 is greater than 0. So what will happen here? So that means it will be what? It will be like that. So the last step is write the solution in interval notation. So what will be our interval notation? So interval notation will be minus infinity, then minus 8, right? Right? And then the union of minus 3, and then what? That is our solution. So let's do one example on greater or equal. So let's do the last one there. So the last one here is x plus 6 all over x minus 5 greater or equals to 0. Solve that. X plus 6 all over x minus 5 greater or equals to 0. So step number 1, we are good. Step number 2, determine the critical points. So what are our critical points? X equals to negative 6 and x equals to what? 5. X equals to negative 6 and x equals to 5. So we now draw the intervals there. So we have 5 here, and then we have minus 6. So these are our intervals. So we can take any point after 6, before 6, I mean. So we can take x equals to minus 7. Here we can take x equals to 0. And here we can take x equals to 6. Then we test. So let's test. So when x equals to minus 7, so when x equals to minus 7, so minus 7 plus 6 all over minus 7 minus 5. Is this greater or equals to 0? Is that greater or equals to 0? So minus 7 plus 6 is what? Minus 1, right? All over minus 7 minus 5 is minus what? 4. Is this greater or equals to 0? Is it? Yes. So this is greater or equals to 0. Let's come to x equals to 0. So when x equals to 0, when x equals to 0. So let's slot in 0 there. So 6 all over minus 5. Is this greater or equals to 0? Is it? It is not, right? So this is not, because this is like negative 6 over 5. And negative is not greater or equals to 0. Now, let's come to the last region there. When x equals to 6, so when x equals to 6. So x plus 6 all over x minus 5 greater or equals to 0. So when x is equals to 6, so 6 plus 6 all over 6 minus 5, is this greater or equals to 0? Is it?
Yes.
Yes. So this is greater or equals to 0. Right. So let's come back to our number line here. Okay. Now, this is greater or equals to 0. That means we include what? This is inclusive, right? Okay. So when you put x to be equals to minus 6, when you put x to be equals to minus 6 here, what did it give you? So minus 6 plus 6 is 0. Is 0 greater or equals to 0? Yes. So what do you do here? It will be like that, right? And the values which are this side. Now, at this point, when you put x to be 5, it will be what? Undefined, right? So when it is undefined, then that means we are not including. So it will be what? It will be like that. Then like that. So what will be our interval notation? So it will be, our interval notation will be minus infinity, minus 6, this one, right? Union 5, and then what? Right? Okay. Valos, Benjamin, Gregory, Ashley, Victoria, Rachel, Bailey, Laura, Adam, Kaveh, Andrew, Destiny, Cole, Abby, Leah, Aldo, Jillian, Remington, Meaton, Eric, Kayla, Relay, Rock, Thompson, Samuel, William, Walkman. All right, see you on Wednesday. So make sure you do your homework.